The chain rule is excuse me, a new technique for differentiating specific types of functions. But really what it's going to be is just an expansion of a previous property or previous properties that we've already established. Before we get into what the chain rule is, though, we want to talk about the key to applying the chain rule. So the key to applying the chain rule, or recognizing when the chain rule should be applied, is recognizing when we have composite functions. So anytime we have composite functions, we're going to need to apply the chain rule to take the derivative of that function. So composite functions, for instance, m of x equals the quantity x squared plus 4 to the third power. So here we have x squared plus 4 and if we looked at, so x squared plus 4 here is that interior function inside those parentheses. If we replaced x squared plus 4, or kind of ignored all of that stuff inside the parentheses, we've got something that looks like u to the third power. So this function is a composition of x squared plus 4 and u cubed. So essentially, x squared plus 4 is being plugged into u to the third. So in place of u, if we wrote x squared plus 4, we would have this composite function m of x. So the key to knowing when to apply the chain rule, knowing how to apply it, is recognizing when we have composite functions, and then being able to identify both the inner and outer functions, or the inner and outer pieces of that composition. So now let's consider the function y equals e to the 0.04x. In this case, y is a composition of e to the u, that's that outer function, and 0.04x is our inner function. So essentially what we're saying here is that 0.04x is being plugged into e to the u. Because if in place of u we wrote 0.04x, we'd have e to the 0.04x, which is that function that we're looking at. So we have our inner function, 0.04x, and our outer function, e to the u, because we're taking this expression and plugging it into this one. So for y equals the square root of 4 minus x squared, we have the square root of u and 4 minus x squared. So in this case, if we take 4 minus x squared and plugged it in for u, we'd have the square root of 4 minus x squared. So 4 minus x squared is being plugged into the square root of u. So we have, again, our inner function and our outer function. And one more example here. In this case, we have y equals the natural log of 2x plus 3. So we have the natural log of u and 2x plus 3. Oh, let me just go back and keep that color convention the same. So we have the natural log of u and 2x plus 3. So what we're saying is we have 2x plus 3 is being plugged into the natural log of u, which again means we can recognize our inner and outer functions.